Hi guys, welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today as we begin a brand new unit on percents and percent applications. Percents and percent applications. Now, this unit is going to rely very heavily on some ideas that we picked up in the proportions unit that we just completed. So if you are uncomfortable with proportions at this point, you may want to go back and check out that series of lessons before attempting this series of lessons. If you feel moderately comfortable with proportions, we will review a couple of those concepts along the way. Just know that we're going to be going through them very, very quickly. Also, I should say from the outset that using proportions to solve percents is not the only way to do it. However, I do usually teach it first to my students, and then we talk about some of the other methods a little bit later on. I like to do it this way because it's pretty easy to understand percents once you have a very solid understanding of proportions. That whole proportional relationship does serve as a very nice guide. So let's go ahead and hop right in here. Today I have come up with a what I consider to be a fun example, a fun time at the math department meeting. So let's take a look at this example, and we're going to use this example to explore how we're going to work with percents. So the problem says, Mr. Nunley has written many versions of his tests over the years. Some are more difficult, some are easier, some are longer, and some are shorter. However, after many years, it is difficult to keep track of which ones are which. As such, he asks the members of Plains Math Department, that happens to be my school, to take different versions of the test for him so he can gauge their difficulty before giving them to students. And as you can see, my department looks extremely excited to help me out here. So let's suppose that Miss Osterwisch takes one of my tests, and she earns a 42 out of 45. And Mr. Mueller takes one of my tests, and he earns 18 out of 19. Miss Niffen earns a 28 out of 30, and Miss Sample earns a 60 out of 64. It is very difficult for us to tell which of these teachers scored the best on their test, because if you look at the denominators in our fractions, each test has a different number of questions. So for example, if I look over here, Miss Niffen only missed 2 questions, but notice there were 30 questions on the test. Mr. Mueller only missed 1 question, but he had fewer questions to pick from. So how are we going to be able to compare each teacher's performance on this particular test? Now, there are several ways that we can do that. Method number 1, we could convert all of these fractions to fractions with the same denominator. And certainly once they had the same denominator, we could compare and see who got the most out of whatever that common denominator would be. However, common denominators are going to be pretty difficult when you're working with 45s, 19s, 30s, and 64s. That's going to be a very, very large common denominator. Method number 2, we could turn them all into decimals by taking the 42 45ths and writing it as a decimal, 18 out of 19, 28 out of 30. We could turn all of those into decimals, and that certainly would make them easier to compare. Or we could use percents, which is the method we are going to talk about today. So here's what I want you to think about. A percent is just a ratio of some number to 100. So we're going to be taking the ratios or the fractions that we have here, all of these ratios, and we're going to convert them to something out of 100. Something out of 100. In fact, the word percent, the prefix per means out of, and the suffix cent means out of 100. And this is going to be pretty simple for us to do. I always tell my students that they should set up a ratio of the part to the whole. In the case of Miss Osterwisch, the part that she got right was 42 out of the whole test, which was 45 questions. And we're going to make that ratio that was given to us into a different ratio being a number out of 100. In other words, if she gets 42 out of every 45 right, how many would she get out of 100? Notice that, unlike my proportions unit, I did not write my unit, given, and find here. The reason for that is sometimes we will know these numbers, and other times we will know the percent and we will have to find one of these missing values. So it's not always, the 42 out of 45 is not always given. The hardest part about this is getting these numbers in the right place, because once I have my proportions set up, I'm going to do this exactly the same way I did in that proportions unit, meaning I'm going to use the means extremes property, and I'm going to say 45 times x and 42 times 100. The means extremes property says that if those ratios have the same meaning or the same relationship, then those two cross products, the means and the extremes, should be equal to one another. Now it's a simple equation that I can solve. 42 times 100 is 4200. And we learned that to get rid of a times 45, we would simply divide both sides by 45. The property of equality teaches us that we can do anything we want in an equation as long as we do it on both sides. And when I do that, this comes out as 93.3. And then I stick my percent on here. So Miss Ostowish got a 93.3 on her version of the test. Now, Mr. Mueller, on the other hand, got 18 out of 19. We're going to see how many did he get out of 100 using the same method. 19 times x, 18 times 100. The means extremes property says that if those two ratios are the same thing, then the means and the extremes will be equal to one another. And we can solve his the same way. 19 x equals 18 times 100, so 18 times 100 is 1800. How do I get rid of a times 19? I divide both sides by 19. His comes out as 94.7%. So he did slightly better. Now that doesn't necessarily mean that he's better at the test. It could mean that my test, the test he took, is easier, but that's not the purpose here. It's not to tell who did better on the test, but rather to gauge the difficulty of the test, because we assume that all of these teachers are all very, very capable. Miss Niffen had 28 out of 30. What is that out of 100? Well, I use my means and my extremes. Multiply the 28 and the 100. Divide by the 30. She got a 93.3. And then we have Miss Sample, who got 61 out of 64. Take the means, take the extremes. The means extremes property says those should be equal. I'm going to multiply my 61 times my 100. And then divide both sides by 64. She earned 95.3. So if we were trying to figure out who did the best on the test or which test was easiest, one or the other, we would look over here and we would say, well, if there were 100 questions, Miss O would have gotten 93.3, Mr. Mueller would have gotten 94.7, Miss Niffen would have got 93.3, and Miss Sample would have earned a 95.3. So we would say Miss Sample did the best on this test. Notice that once all of these are written as the same denominator, 100, it makes them very easy to compare. By the way, this would be a nice time for me to throw in that Miss Osterwish is a wonderful teacher in her own right, and she does have her own YouTube channel. So if you get an opportunity, I would recommend that you check her out and like and subscribe her page as well. Now, the idea here is just this idea of realizing that we can represent these as something out of 100. And there are a lot of different types of problems that we're going to talk about over the next several lessons that show where this might be useful. The trickiest part of working with percent problems, though, is the same thing that was difficult with working with proportions. That is, getting our numbers into the right position. So we're going to focus this particular lesson on how to get those numbers in the right spot. And here's the pattern that I teach to my students. Just like in our proportions unit, we're going to have a unit ratio over here on the left. And it's most of the time going to be a part of some kind compared to a whole. Notice we have what would have been the given ratio in our proportions unit is now our numbers ratio. We're going to have some number compared to some other number. And then we're going to have, instead of our find ratio over here, we're going to have a percent ratio, some percent compared to 100. So a number part, a percent part, a number whole, and then my percent is always out of 100. And in most cases, we can solve these by thinking about this pattern. Some part is some percent of some total. Some part is some percent of some total. And you'll notice that I have these color-coded. See this some part is, that's purple? That's this piece right here. That's the number part. Some percent, notice it's in red, matching to the percent. That's the percent part. And then over here in green, you have sum total, which I've color-coded to match the spot over here. Sum part is some percent of sum total. So when I give you an example like this, what is 40% of 85? This is a very simplistic example that's designed to illustrate what we're going to be doing here. When I read this, I notice what is. That's my part. That's my number part. Something is. Notice that I don't know the number part. Some percent, that's the 40%, of 85, that's my whole. We have a number part, a percent, and we have the number whole. So when I go to fill in my proportion, part whole, my number part is unknown, my percent is known, and my whole is also known. The hardest part of a percent problem is what you just did, getting these numbers in the right place. Because once the numbers are in the right place, the means extremes property allows us to solve it just like we did in our proportions unit. Now notice I glossed through that part. I glossed through that part because this is something you should already be pretty familiar with. I'm not going to be investing a lot of time in the solving of the proportion because the difficult part is getting the numbers in the right place. So that's where we're going to focus our attention today. And then I just went through and filled in our answer into this original sentence. What is 40% of 85? 34 is 40% of 85. And notice I color-coded that 34 to match its position up here at the top. Clearly, I'm very, very proud of the fact that I took the time to do that. Here's one for you. If you feel pretty comfortable finding your parts and wholes, I'd recommend that you pause the video, try this on your own, and then restart the video to see if what you did matches what I'm doing. I'm going to go ahead and assume that if you wanted to do that, you did, and I'm going to keep right on rolling here. Notice 15 is, that's my number part, 35%, that's my percent, of what? That's my whole. So when I go to set up my proportion, the number part is 15, the percent is 35, and the whole is my unknown. Notice that of goes with my whole. Of goes with my whole. That's how I was able to identify it, and so I'm color coding that green. Again, you've done the hardest part. The easy part is what's left. The means extremes property. Multiply your 15 and your 100. Divide by 35. And there is your solution. 15 is 35% of 42.9. Again, here's another example. See if you can identify what your parts, your wholes, and your percents are. I'm going to assume you've paused the video and already done that. I'm going to keep right on rolling. 28 is, well, that's my part. It's a percent of this whole. 28 is my part, 58 is my whole, my percent is unknown. So part is 28, percent is X, whole is 58, and you've done the hardest part. Means extremes property, multiply, divide both sides by the 58, and you get 42.27%. Notice I did go ahead and round this answer off to the nearest tenth. You could leave it as 42.27 as well. Just know that you've got to be careful with whatever directions your teacher happens to give you. Now, I do have 3 more of these. If you're feeling pretty confident, I would recommend that you try it on your own with a video pause, maybe even fast forward through my explanation and then check your answer. And then if yours doesn't match mine, go back and watch the video to see if you can figure out why. I'm going to do this much more quickly this time, so here we go. What is, that's my part, 92%, that's my percent, of 21 is my whole. So when I go to fill in my proportion, my part is unknown this time, my percent is known, and my whole is known. Again, that's the difficult part. The rest is simply computation, and you can certainly use your calculator to help you with that. You get 19.32, so 19.3 is 92% of 21. Try another one. How about this? There's your part, there's your percent, and there's your whole. When you go to plug these in, you have your number part, your percent part, and your whole is unknown. That's the tricky part. So we cross multiply. That's the means extremes property. Multiply our 17 and our 100, and then divide both sides by 42. You get 40.48, which I then rounded off to 40.5. Make sure you check your teacher's directions for how to do that. One last problem. 116 is what percent of 90? Again, you've paused the video and tried this on your own. 116 is, that's your part. What percent, your percent is unknown, of 90 is your whole. So when I plug this in, 116 is my part, my percent is unknown, 90 is my whole. Notice when I cross multiply and solve this one, I get a solution of 128.8 repeating percent. This is a really good time for me to point out that it is possible to end up with a part that is larger than a whole. My part here is bigger than my whole. Some students start assuming automatically that the bigger number is the whole, and that is not always the case. You're cautious and conscientious about how you're setting that up. Remember, they're saying, how does 116 compare to 90? Well, 116 is 100% of 90, or all of 90, and it's 28.8 repeating percent more. So the 116 is all the 90 plus some extra. Don't just assume that the bigger number is your whole. Now, if you were in my class, I would continue this on. This is just a basic introduction to the idea of using proportions for percents. In my class, we would go on, we would talk about more general applications and how this can be useful for you. But for the sake of keeping this video brief, I'm going to go ahead and do a split here. So make sure that you check out the next video, which talks about applications of percents, more like you might see them in the real world. Hopefully this has been useful for you. I do appreciate you checking us out. Make sure that you ring that bell to turn on your notifications so you receive anything new coming from Nunley Math. Also make sure that you give me a big thumbs up. That certainly would be appreciated. All right? You guys take care of yourselves. Look forward to talking to you again soon. Take care. Bye-bye.